Hi everyone, and thank you for your interest in ElasticBLAST. My name is Christiam Camacho, and I'm the technical lead on this project at the National Center for Biotechnology Information, which is part of the National Library of Medicine at the United States National Institutes of Health in Bethesda, Maryland. In this presentation, I will briefly go over what ElasticBLAST is and when it is applicable. I will also highlight its benefits and features, and I will briefly describe how it works, how it performs, and where you can get it. Let's get started. In brief, ElasticBLAST is a tool to help you run BLAST faster. It is a command line tool designed to facilitate running BLAST on large amounts of query sequence data against well-annotated, commonly used, and user-provided BLAST databases. This is not possible in the NCBI BLAST web service because it's a public shared resource, and it would take custom tools to be built around the BLAST Plus command line tools. ElasticBLAST is under active development. Next, I will provide an example of when ElasticBLAST will be helpful. mRNA annotation with functional and biological processes is an important step in developing an understanding of the biological complexity of an organism. This process typically involves the integration of multiple biological databases and software tools. In this process, BLAST is used to align an assembled transcriptome against annotated databases of proteins or nucleotides. These alignments are the first step to identifying close and/or distant homologous genes, proteins, and functional domains to generate new annotations on the newly assembled transcriptome. An example of such a process would be the annotation of Opuntia streptacantha, commonly known as the prickly pear or nopal, which is shown in this picture. Its assembled transcriptome is composed of about 474,500 transcripts, composing 217 million base pairs. Among its benefits, ElasticBLAST opens the door to virtually unlimited storage and compute capacity. It also enables you to take advantage of the cloud's pay-as-you-go model, in which you only pay for what you use with no upfront capital expenses. Additionally, whenever possible, ElasticBLAST aims to hide the complexities of managing compute resources to run BLAST on the cloud. ElasticBLAST supports all BLAST programs, including those not supported on WebLAST, such as tBLASTX and RPSTBLAST10. It also supports user-provided and a growing set of BLAST databases updated regularly by the NCBI. Furthermore, taxonomic filtering of BLAST databases is supported. ElasticBLAST is open-source software and runs on major cloud service providers. It supports horizontal autoscaling, which is the ability to adjust the number of compute instances automatically up to a predefined limit based on its workload. It's also worth mentioning that ElasticBLAST supports spot or preemptible instances, which provide compute capacity at a discounted price. Next, we'll give an overview of how ElasticBLAST works. ElasticBLAST is implemented using Docker. It uses object storage such as AWS S3 or Google's GCS for BLAST databases, queries, results, and ancillary data, and Kubernetes and GCP and AWS Batch for cloud resource management and job orchestration. Next, we'll take a detailed look at the architecture and workflow in ElasticBLAST on AWS, focusing on the cloud operations. Please note that the workflow and architecture is similar in GCP, but it uses different technologies, so for brevity, we'll only examine AWS. We'll start with the client, which could be ElasticBLAST running on your laptop or a cloud instance, buckets for storage of BLAST databases, results, and queries in the AWS cloud. ElasticBLAST creates a CloudFormation stack, which in turn creates multiple cloud resources. This is a representative sample of the resources ElasticBLAST manages on behalf of its users. All of these resources have reasonable defaults, so you can focus on running BLAST as part of your research. Next, ElasticBLAST submits jobs to AWS Batch, which schedules set jobs on the resources it created. These jobs run on EC2 instances, which download the data they need, run BLAST, and write the results to the user's result bucket. Finally, after ElasticBLAST completes its job, the client invokes ElasticBLAST delete command to shut down all cloud resources. The ElasticBLAST source code and documentation can be found on GitHub. The ElasticBLAST program itself can be easily obtained from PyPy and Bioconda. Now I'd like to show you an example of ElasticBLAST performance. In this example, MegaBLAST with default parameters was used to align the Nopal transcriptome described earlier against the NT-BLAST database. This comprises of 474,000 queries, totaling 217 million bases, versus 69 million sequences in NT, which contains about 432 billion bases. This blast search is too large to run on the NCBI Web Blast service. As shown in the first column, running BLAST on a single server with 32 virtual CPUs and 128 gigs of RAM will take about 7.5 hours to complete and cost about $11, whereas ElasticBLAST on 10 times as many virtual CPUs will take about 40 minutes and cost about $10. This assumes on-demand pricing at AWS. If one is willing to accept a longer runtime, spot instance pricing reduces the cost to just under $4 and taking a bit over an hour to run. As mentioned earlier, ElasticBLAST is still in active development, so we're planning to work on automatic shutdown of all class resources upon completion, job submission on the cloud to reduce the work done on the local machine, performance optimizations, and a publication. If you would like to try ElasticBLAST, the NCBI is looking for volunteers to participate in an alpha testing program. You can do this at this conference's Collaboration Fest on July 31st and August 1st, 2021. If you're interested in participating, please contact us. Here are a few links to ElasticBLAST resources. In closing, I would like to thank my colleagues at the NCBI, without whom ElasticBLAST would not exist. Many thanks to their efforts and dedication to this project. Thank you for listening.